Now let's do a little bit on graphing these polar curves. Remember, in the parametric representations also we used this website to graph those parametric representations, but this is not the only possible way to graph a parametric curve, right? Now even in the calculators you might be able to do that, but the code that you are going to use to come up with the parametric curve will totally depend on the platform that you use. Okay, so I am only teaching how to use this website to graph the parametric representations, because now even for the polar coordinates we consider it as a parametric representation and use these things to use the same technique to graph the parametric curves, the polar curves. So that's why I am basically focusing on representing the parametric curves, because polar curves will also be considered as a parametric representation and graph in the same way. Right, now remember we used a special way to feed the parametric information to this website. The way we do is we have a bracket and first write down the x coordinate, and here x coordinate, the parametric representation of the x coordinate, here it is t to the power 4 minus 3t squared, so it should be t to the power 4 minus 3t squared, right? 3t squared. And for the y coordinate you just separate it with the comma and write down the required parametric expression for the y coordinate, which is t in this case. So here you should have t, right? And like the website itself will automatically indicate a suitable range for this parameter t, so we can use whatever the number we prefer, right? So then it will be plotting the curve for the t values in between these two numbers, right? If you can't remember this one, please go back to plotting the parametric curves and study that video first and then come back to this one, right? Now for the polar curves also we treat it with the same way, right? Say if we have to plot let's say our cardioid, right? That is r equals 1 plus sine theta, right? Now what we need is the x coordinate as well as the y coordinate, and here we know that x equals to r cos theta and y equals to r sine theta. Now here we are kind of using both polar representation and the Cartesian representation in the same diagram, right? So that's why we have these relationships. And here r is equal to 1 plus sine theta, and this is cosine theta, and this is equal to 1 plus sine theta sine theta, right? But the thing is, now in this website you cannot indicate the letter theta, right? Only if you mention the letter t it will recognize as a parameter, so we just have to rewrite everything in terms of t, right? Sine t, cosine t 1 plus sine t sine t, right? And then we have to use these two things as the x and y inputs, right? So we have to have another. Now I will disable this graph, and how are we going to plot it? We need two brackets, and for the x coordinate we have 1 plus sine t, and it is also inside a bracket, times cos t, comma, you have 1 plus sin t times sin t, right? And t runs from 0 to 2 pi, right? See, we got a nice cardioid. But now suppose if you need to draw it from 0 to pi by 2, then we just have to write pi by 2, right? And how about pi? See, it completes this kind of a half circle. And if it is 3 pi by 2, it will complete the rest, right? So likewise, you can draw all the parametric curves written, all the polar curves written in a parametric format like this. And this is 2 pi. And I will do one more example for this curve plotting. How about this one? R equals sine 8 theta by 5, right? Now in the similar way, we have to do that. X is equal to r cos theta, y is equal to r sine theta. Therefore this will be equal to sine 8. Now I am replacing theta with t, right? And this will be cos t, and this will be sine 8t divided by 5 times sine t, right? And if I write these two in the parametric representation, now I am disabling the second curve and enter. Then open a bracket, you have sine 8t divided by, not that way, this divided by 5, and cos t, comma, sine 8t divided by 5 sine t, right? Well, I don't think we need this bracket. Yeah, so this is the parametric representation. And how about the values? See, if we start from 0 and if we go up to pi by 2, you have this one. How about pi? It becomes this. How about 3 pi by 2? This is pi by 2. How about 3 pi by 2? We will get this one. And how about pi, 2 pi? You will have something like this, right? But can't, like, the thing is, now see, for the cardioid, right, for the cardioid, if you keep on increasing this value of the parameter after 2 pi, you will get the same diagram, right? But that is not like this. 2 pi is not a universal endpoint for all the parametric curves. Like now for this particular curve, this cardioid shape, after 2 pi the curve will repeat, but that doesn't say that for this third curve also it should repeat after 2 pi, right? There can be a different number, an endpoint, so that repetition starts after that endpoint. So we should be able to find that endpoint. So how are we going to find that endpoint? So basically what you should ask from yourself is, how many cycles do you need to have before repeating happens, right? Like how many complete rotations are required until the curve starts to repeat itself. That means that can be found by this, right? Now remember, r is a function that depends on theta, right, which is sine 8 theta by 5, right? And a complete rotation means theta is increased, like 2 pi is added for theta. When 2 pi is added to theta, it will complete a one full rotation. And if 2 thetas are added, then it will come, sorry, not 2 thetas, 2 times 2 pi is added, then it will complete 2 full rotations, right? So if at a certain stage, when n number of 2 pi's are added, right, when n number of 2 pi's are added, if you end up at the same stage, that means we have successfully completed, like that means at the end of this many rotations, the graph will be at its very first starting point. That means if we keep on increasing after this point, you will be getting all the previous values, right? So it's kind of the critical point for the graph to repeat itself, right? So it's like we are going to find how many number of rotations are required for the graph to start repeating itself. So we are going to find this n, right? So that can be found by the equation we have for r, which is this one, right? Hence, if you substitute these terms, you will get sine theta times, now if you substitute this one here, you have not theta, 8 times theta plus n 2 pi over 5 to be equal to sine 8 theta over 5, right? And you can simplify it like this. So here we have to find this n value, right? So now we anyway know that for the sine curve, for the sine trigonometric function, if we have a certain angle and if we add 2 pi, then you will get the same value, right? And this is true for any even, sorry, no, not, yeah, I mean, if you add 2 pi, you will get the same thing. But if you add 3 pi, you will not. Okay? And if you add 4 pi, you will get the same number. But it will not be true if you add 5 pi. But if you add 6 pi, you will get the same term. So, if you add an even multiple of pi, then you will get the same number, right? Same, like, I mean, you will end up at the same originating position, right? So in other words, for this equality to hold true, we can say that if this becomes an even multiple of pi, then you have this equality in a very nice way. In fact, what we really need is for this term 16n pi over 5 to be a even multiple of pi, right? Now remember, we are trying to find this n, okay? So now you can write this one as n times 16 pi over 4. Now what will happen if n equals 1? Then it will be 16 over 5 times pi. It is not a integer. And when n equals to 2, it will be 2 times 16 over 5. N equals 3, again it will be just a fraction, right? But the first point that you have is for the n equals 5, then what you will get is 5 times 16 over 5, right? So these two 5 values will get cancels out and you are remaining with 16 pi, which is an even multiple of pi, which in other words, after this number of rotations, or in fact after 5 complete rotations, the graph will start to repeat itself. So doing 5 rotations means we are having 5 times 2 pi angle, right? So that means 10 pi. You can see that from the diagram here, right? Now I am disabling the cardioid and we are back into this one, right? Now you can see when I am increasing the value, let's start at pi, right? Now remember the point I got is 10 pi, right? So what I am saying is starting from theta equals to 0, you should go until 10 pi for the diagram to repeat. That's my claim, right? And you can see that from this graphing calculator as well. So we are starting at 0, you can see, and here let's end at pi over 2. We have a very small portion of the angle. And how about pi? We have this much. And how about 2 pi? We have this much. About 3 pi, we have this. See, it starts to complete the diagram when we are increasing the endpoint, but still there are no any repetitions, right? Still keep on adding some values, but after this one, and if you increase further than that, you can see there is no difference happening to the graph, right? So it's like it is after 10 pi, you will be plotting the graph, you will be repeating the graph on itself, right? So it's like we are drawing the same curve over and over again, but until 10 pi you will be drawing a new curve, okay, right? And there are some more nice examples in the book, so I recommend you to go over those and try to plot those graphs as well.